highlight is this is a review section about dividing radicals. It should come after section 4.5, and you will definitely need this for section 4.6. So this is, again, we did multiplying, we did simplifying, we did adding and subtracting and combining radicals, but this is about dividing radicals. So the simplest form of radical has no perfect square as a factor of the radicand. Okay, so the simplest form does not, the radicand does not include a perfect square. Alright, the second vocab expression is to rationalize a radical expression. That means that you do not have a radical in the denominator. And then the last one, the conjugate of a radical expression. So a radical expression could be like the square root of a plus the square root of b. The conjugate of that is the square root of a minus the square root of b. All right, so we're going to use these terms or these expressions to help us divide radicals and rationalize radicals and put them in their simplest form. So if you look at your note sheets, you've got a few examples. All of these have radicals in the denominator. So we're first going to look at the quotient property. The quotient property of radicals it says that the square root of a divided by the square root of b is the same as the square root of a, or the square root of the group a divided by b. So those are the same thing. So now when we look at rationalizing and simplifying each radical expression, our first step is going to be to rationalize the radical. So remember, you can always multiply by 1, and any number over itself is 1. So in order to get rid of the radical in the denominator, we're going to multiply by 1, but we're going to do that in the form the square root of 3 over the square root of 3. Square root of 3 over square root of 3 is 1. You can multiply any number by 1, and it doesn't change. It changes how it looks, but the number itself does not change. So 2 times the square root of 3 over positive or negative 3. And that's your simplest form. Now looking at the second one, again, we're going to get rid of the radical, and we're going to do that by multiplying by 1. And it looks like the square root of 12 over the square root of 12. That number is 1. We can always multiply by 1. So 6 times the square root of 2 times the square root of 12 becomes 6 times the square root of 24 divided by 12 times the square root of 12, which is positive or negative 12. Now we can simplify this radical. Okay, we can simplify that radical, 24. It's the same as 6 times the square root of 4 times the square root of 6 over 12, which is the same as 6 times 2 times the square root of 6, which is 12. So again, we've got plus or minus 12 times the square root of 6 divided by 12. Now 12 divided by 12 is 1. So our final answer here, since these cancel out, is positive or negative square root of 6. When we actually take the square root of 6, it's going to be positive or negative, so we don't really need this positive or negative sign. It's not wrong if you have it, but it's just unnecessary since the square root of 6 is going to be positive or negative square root of 6. Right, so this is, oops. This is your final answer, square root of 6. All right, then looking at the next one, square root of 20 over square root of 6, we got to multiply by 1. So square root of 6 over square root of 6 is 1. And we end up with square root of 120 over plus or minus 6. And again, since we're going to take the square root of 20, we don't really need that plus or minus 6 there. Because when we're multiplying, it's going to come up again in our other radicals. If it makes you feel better to keep it, go ahead and keep it. It's not wrong, but it's just not necessary. All right, so the square root of 120 is the same as, let's see, 12 times 10, or 16. Let's factor out 120 so that we can see where these numbers come from. So we're looking for the largest perfect square. So 12 and 10, neither of those are perfect squares. Then we've got 2 and 6, and 2 and 5. So it looks like 4 is our largest perfect square here, because then we have a 2, a 3, and 5 that are just kind of left over. So it looks like 4 is our largest perfect square. Okay, so that is equal to then square root of 4 times square root of 30 over 6, which equals 2 times the square root of 30. Again, it's plus or minus 2, but since we still have that radical there, we don't really need the plus or minus 2. Equals 6. And then 2, we can simplify 2 divided by 6, which is 1/3 times the square root of 30. And again, it's plus or minus, but we still have that radical 30. So we don't need it. We don't need that plus or minus. So then our 1/3 times the square root of 30 is the same as the square root of 30 over 3. So that's really its simplest form. You could say 1/3 times the square root of 30, or you could say the square root of 30 over 3. It's the same answer. All right, so now when we have when we have an expression that has adding or subtracting radicals in the denominator, we need to multiply both the numerator and the denominator by the conjugate of the denominator. So that's how we're gonna rationalize this expression, multiply by the conjugate of the denominator. So the conjugate of the square root of 10 plus 4 is the square root of 10 minus 4. So we're still gonna multiply by 1. The square root of 10 minus 4 over the square root of 10 minus 4. So 20 times the square root, and now we have to distribute on the top and the bottom. So 20 times the square root of 10, and we'll simplify later. And then 20 times negative 4 is negative 80. And that's over. Now, if you remember your shortcut for the difference of perfect squares, a squared minus b squared is a plus b times a minus b that's what we have here, where square root of 10 is our A and 4 is our B. So we're going to end up with A squared minus B squared. So that's the square root of 100 minus 16. So it's that whole group on top divided by that whole group on the bottom. So we can simplify. So we can't simplify the square root of 10, and we can't combine our terms on the top. So we're left with 20 times the square root of 10 minus 80 over, now this is plus or minus 10 minus 16. All right, so let's continue this. We're going to move this all over here to simplify. So we've got 20 times the square root of 10 minus 80 over positive 10 minus 16, which is negative 6, or 20 times the square root of 10 minus 80 over negative 10 minus 16, which is negative 26. All right, so now we can simplify both of these. So if we use the positive 10 as the solution for the square root of 100, then we can simplify this by factoring, I think maybe 2 is our largest. So we would have 10 times the square root of 10 minus 40 over negative 3. That's one solution. Our second solution would be, again, I think 2 is like our largest. So 4, we would have 10 times the square root of 10 minus 40 over negative 13. So neither of the, you can't simplify either of those, it doesn't look like. So that's as simple as you can go. But since you were adding and subtracting, you had that positive or negative 10 in the denominator, you have 2 different solutions that look different. All right, let's look at the next one. Again, you have a sum or a difference in the denominator. So we need to multiply by the conjugate. So we're going to multiply by 1, but it's going to be in the form of the conjugate of the denominator. So we're going to multiply by 2 plus the square root of 3 over 2 plus the square root of 3. So if we distribute 16 to the numerator, we've got 32 plus 16 times the square root of 3 over A squared minus B squared, which is 4 plus 4 minus 3. Okay, now again, we're going to have 2 answers because we are adding or subtracting square root. So 32 plus 16 times square root of 3, we cannot simplify that. So our one answer would be 32 plus 16 times the square root of 3 divided by 4 plus 3, which is 7. And our second answer, we would have 32 plus 16 times the square root of 3 divided by 4 minus 3, which is 1, which if you write this in simplest form is just 32 plus 16 times the square root of 3. right, and then finally, let's look at the last problem. Example C. So 25 divided by the square root of 2 plus the square root of 5. Again, we're adding or subtracting. In this case, we're adding. We are adding radicals, taking the sum of the two radicals. So we need to multiply the numerator and denominator by the conjugate of that radical. So we're going to multiply by the square root of 2 minus the square root of 5 over the square root of 2 minus the square root of 5. And that's 1. That's the same number over itself, so we can do that. And now we have to distribute 25 to the square root of negative 2 minus the square root of 5. So that equals 25 times the square root of 2 minus 25 times the square root of 5. Now those do not have like radicands, so we cannot combine them. So even though 25 is the same number, the square root of 2 and the square root of 5 are not the same, and those are the radicands, so we cannot combine those. And then that's over a squared minus b squared. So a squared plus or minus 2, b squared is plus or minus 5. Okay, so you see that we have we simplified two radicals in the denominator, so we have two solutions for each of those. So when we simplify this, our first answer is 25 times the square root of 2 minus 25 times the square root of 5 over, if we use positive 2 and positive 5, that's 7. And if we use negative 2 and negative 5, that's negative 7. So it's over positive or negative 7. Or, let's start the color. Or 25 times the square root of 2 minus 25 times the square root of 5 over positive 2, negative 5, which is negative 3. Negative 2, positive 5 is positive 3. So it's divided by plus or minus 3. Now, neither of these we can't simplify because 3 does not go into 25 and 7 does not go into 25, so that's its simplest form. So again, you'll need those for the next lesson, so please jot down any questions you have.